What's up, guys? It's LeetCoder. This is LeetCode 3, longest substring without repeating characters. Given a string s, find the length of the longest substring without repeating characters. For example, we have our input s equals abc, abc, bb, and the output is 3. And if we read the explanation, the answer is abc with the length of 3. Because ABC is the longest substring that does not have a repeating character. Okay, let's think of a brute force algorithm that can solve this. All we have to do is check every possible combination of substrings until we get to the very end. And then we return the longest substring that does not have repeating characters. In order to do that, we would have to check this substring, this, and so on all the way to the end. Then we start with a B, BC, BCA, go all the way to the end, and so on. If we think about how to program this, if we write pseudocode, it'll be something like for I equals 0 goes to n, for j starts at I and it goes to n, and then for k starts at I and it goes to j. If we think about the time complexity, well, it's 3 loops, so it's pretty obvious that it's going to be O of n cubed. Clearly, this algorithm is way too slow, and there must be a better way to do it. We want to think about reducing the time complexity by adding a little bit to the space complexity. First, we check this A here. Then we check AB. Then we check ABC. So far, so good. ABC is a substring that does not have any repeating characters. Now we get to this A here. Now we can't just add it to the substring because that would mean that this substring has repeating characters. So what we have to do is remove all the characters from the substring, our current substring is ABC, until we reach the first A. In this case, it's the first element, so all we have to do is remove the first element, and we get BCA. Then we go to the next character, B, and again, we remove until we find a B in the substring. So we get CAB. Then we do the same thing with C. It's going to be ABC. And we get to this B here. This is where it gets interesting because we can't just remove the first element from the substring. We have to remove until we find the first B in the substring. So in this case, it'll be removing 2 characters. So now our new string will be CB, and then we get to this B, and again, we have to remove C and B from this substring, and we get B. Now, how do we program this? We need to think about a data structure that allows us to check if an element is in the current substring in O of 1 access time. And of course, that would be a set. So let's do it with the set now. So first our set's empty, and we get to this A, we add A, and the current substring, call this SS, is A. Then we get to this B, and this, okay, there's no B in the set, so we add B to the set. Then we get to this C, same thing, we just add the C to both. Then we get to this A. Okay, A is in the set, so we remove it from the set, and then we loop through the current substring from the beginning until we reach an A, and we remove all elements up to that A. We remove this A, then we add A to the set, and we add A to the substring. And if we keep going, so the next element will be B. So this set will remain the same, but the substring will change to CAB. And then we get to the C, the set will remain the same, but the substring will be ABC. And we get to this B. So this is where it's interesting because now we have to remove both of these elements, the AB, and we have to remove both of those from the set, right? And now we can add this B here, and then we can add the B here. Again, we loop through the substring until we find the B. Okay, so we remove those, and we remove all the elements that we removed from the substring from the set. And now we add B to the set, and B is our substring. So that's really all there is to it. The trick is to realize that you don't have to loop through and get every combination of substrings. You just have to keep what's called a sliding window. So first the window is this, then it's this, then it's this. Now once you get to the A, the window kind of just slides a little bit. It removes the first A and adds a new A. Then it slides again with this B. Then it slides again with this C. Now we get this B and it slides again like that. And we get to this B, it slides again like that. Now in terms of time complexity, this is going to be O of 2n, which is equal to O of n. And it's O of 2n because we are looping through the substring on each iteration until we reach the new character. Now we could improve upon that by keeping another data structure that will allow us to have O of 1 access time to know exactly where the character is in the current substring. But I'm not going to go through that in this video. I think it's an interesting exercise for the viewer to do. In terms of space complexity, it's going to be O of the minimum of n, which is the length of the entire string, the input, and m, which is the character set. Because if you think about it, the set can never contain more than the total number of characters in the character set. For example, if it's only lowercase characters from the English alphabet, the set will never have more than 26 characters in it. And that's it. Again, we have to think about when we have our brute force algorithm of O of n cubed, how can we add some space complexity and reduce the time complexity by doing so. And in a lot of these array problems, you can usually do the algorithm in O of n time. So that's kind of the goal that you're shooting for. And of course, one thing I forgot to mention, but it should be fairly obvious, while we're doing this algorithm, we just have to keep track of the current maximum. So if the length of the current substring is greater than the maximum, we just set maximum to the length of the current substring. Now, before we get to the code, if you found this helpful so far, please give a like and a subscribe because it really helps the YouTube algorithm. With that said, let's get to the code. First thing we want to do is define our variables. So we'll have a set, call it scene, we'll have a max, initialize it to 0, and then we'll have our substring, which initially is nothing. Then we'll go through and we'll loop through each character in S, and we'll do our logic here. First, let's start with the very basic logic, and we're just going to add things to the substring. So we'll say substring plus equals character, and then we'll also add to our set. Then we'll get our substring length here, and if the length of the substring is greater than max, then max equals the length of the substring. And we'll return max at the end here. Okay, let's run this code and see what happens. This should give us, I believe, the full length of the string because we're not checking for things in the scene set yet. My expectation is the output will be 8. And there it is, so that's 8. Okay, so now all we have to do is add the condition if character is in scene. So here we have to remove characters from scene and remove characters from the substring until we reach the character that is equal to char. Before we do this, we need another variable. We'll call it left index, and this will represent the left index of the substring. So initially it'll be 0, and we're going to be using that in this condition here. So we'll do while true, we're going to get the current character, which is equal to s at left index, and then we're going to remove it from the set. We're going to remove it from the substring, and we know it's the first element of the substring, so we can just say substring equals substring from index 1 all the way to the end. And then all we need to do is check if current character is equal to character. Because if it is, then we know that we've reached the character in the substring and we're done with the loop and we can continue with our logic. So all we do is we check if current character is equal to character, then we break out of this loop here. Oh, and there's one more thing we need to do, and that is iterate the left index. Otherwise, left index will always equal 0, and that won't work. So this left index needs to represent the left index of the substring. So let's run our code here. And we got the right answer. To save some time, instead of mentally going through one of the examples, which is what you should do, I'm just going to use example 3 here in the test case and run the code and see if that works. And boom, it works. So let's submit here. And that's it. Again, we started off with our brute force solution. We realized it was O of n cubed. And then we thought about how we could add some space complexity to reduce the time complexity. And we did that with a set here. And we also were a little bit clever with our algorithm, and we didn't loop through multiple times. We just looped through once while keeping a sliding window of where we were. Now you could improve this a little bit by using another data structure instead of looping through the substring again until you find the current character. But I'll leave that as an exercise for the viewer. And that's it. Let me know down in the comments if there's any problem you'd like to see next. And make sure to hit that like and subscribe button. See you next time.